Okay, so let's just try out a little regression, and let's try it out here in rapidminer. Now, I started with this. I didn't have this. I had this, basically. I didn't have this, and I did have, and then we're going to put in this. So actually, let's take a snapshot of this first, so I don't forget what I have here. Okay, so I just took a snapshot. Now I'm going to remove this one. How do I remove it? Maybe cut it or delete it. And let's remove this one and delete it. Okay, so now we have this. And so basically here I got some data. Let's see, this was from the data sets that are in rapidminer. And I tried this one called labor negotiations. You can see the kinds of the names of the variables here and the types of data. So you can see that the first one, duration, is an integer. Next one is a real number, nominal, integer, nominal, and so on. So some of this is nominal data. Now I got an error message when I tried to use this, as maybe we'll see. So after you get the data, you have to say which is going to be the output variable. So you click here. You have to bring in this thing called set role. Let me get rid of this and do it again. So I'll delete that. And let's try set role. So you search in here for this. So then you just drag here, and it seems to connect it automatically. And then, so now this is selected. So I have to click here, so I have to go over here and choose the attribute that I want to predict. So I'm going to try this one. I don't know anything about this data set, so I don't really know what I'm doing. And then target role is a label. And I'm not quite sure what this means. So I saw this in a video, so I'm just going to try that. And now you see this symbol here. So this says there's some problem. So let's click on that. And it says linear regression cannot handle polynomial attributes. I forget exactly what they mean by polynomial attributes. But I'll click here, help me solve it. And so they did something called, I guess polynomial attributes maybe means nominal attributes. I'm not quite sure. Yeah, that's right. It's a really strange name for nominal, because polynomial definitely sounds like a number, but when they say polynomial, they're thinking of that word polynomial. So poly, maybe you know, in Greek means many, and nomial, I guess, means name. So they're thinking of it as kind of a word for nominal data, which sounds crazy to me. But anyway, that's what they're calling it, polynomial data. Anyway, this will transform nominal data to numeric. I'm not quite sure even how it does that, but I'll just let it do it. Now, there's still something here, and it says linear regression cannot handle missing values. So if we go to here and double click on it, go to here, and how do we view this data now? I forget. The only way I know to view this data is to go here and do a new process. Let's try that. And do we want to save this? Yes. And use the data access and get files. Retrieve here. Put that here. And then double click on it and get this data again. So I'm just sort of get the data again. It was called this one, I think. And click that, and then connect it to the output. This is the only way I know to view it. This is probably a better way to do it than this. And then click Run. So here we can see the data, and here you can see that there's a lot of missing values. All these question marks mean missing value. So that's going to be a problem for running regression with this data. Click back here on Design, but I want to go and find my other model. Now I don't know how to do that. But I'll try going up to here and open process. And here, I had saved it, so there it is. So I won't save this one here. So this is it. Okay, so now, clicking on this again, it says can't handle missing values, so help me solve this. And missing values. Actually, I think in my last model I put the missing values over here, but here it put it here automatically. So I'll accept that. Now there's still an issue. What's that? Replace missing values. Should be okay. Okay, so it put it over here, and then it kept giving me a problem. But I just searched for replace missing values. I found it here. There are different ways to replace missing values. We haven't talked about how that's done. But anyway, let's just accept it for now, just so we can get this running. So now we have this process. It doesn't have any exclamation mark there, any warning. So maybe it will run. And if we run it, it's supposed to do linear regression, which we have yet to talk about. We're going to talk about it, but let's just try it. So we click here, it runs it, and it's done. And clicking here on descriptions, we get the equation for linear regression. So as I said, we haven't discussed what that means yet, but we will. So anyway, we ran it here. This was linear regression. Let's try it once more. And here the data gives you a little bit more detail about the so-called model. And go back to here, and let's just save this, save it, okay. And now let's try a new process. So I guess we go here, maybe click new, start a new blank process. And let's do more or less the same, but let's do it on this data. Real estate price prediction from Kaggle. So you can download it. I just downloaded it. And now I want to import this. I think they say that it's better to import it into the so-called repository before you use it. So let's try that. So I think they say that if you import it, things happen more quickly when you're running the models and so on. But, that is, if you import it into the repository. So let's try doing that. Import from my computer, and I'll go to go up. And I want to find downloads here. And let's go to here. Where is it? Okay, so here it is, called realestate.csv. So let's, what do we do here? I guess next. Okay, so it seems to, no, it hasn't finished yet. So it's showing me what's in there. Shows something about the house age. And I think this is the distance from the MRT station. This is the number of convenience stores, I guess, in the neighborhood, and so on. And here's the house price. Let's keep going. I don't know what we need here, but probably it will do it by itself. And next, format your columns. Maybe it's going to do this. Replace errors with missing values. I don't know what that does, but let's hope that we don't have to do that. And then finish. Okay, so now we have the data. We can see it here. Maybe it's in our repository now. And if we go back to here and we retrieve data, so we want to get, let's close this thing and go to data access and retrieve and put that on here. And then double click it and go to the, I think it was under samples and data maybe. No, it's not there. Okay, so it's right here. So if I go here, maybe it's under, I don't know where this is. Real estate, maybe this is it. Okay, now it has this. What's that? Parameter repository entry access is a, this may not be portable when sharing the process. Okay, I don't know what that means, but okay. Anyway, okay. So let's try this again using basically the same setup that we had before here. So I don't think there are any missing values, but maybe we can check that first. So let's try that first. Let's connect. This is the only way I know to see. Well, anyway, let's try that. And it doesn't look, let's see. It doesn't tell me whether there's missing. Doesn't look like there's missing. So I'll assume that there's no missing, and then maybe it will alert me if it actually is missing. Let's go back here again to design, and let's add in the set role. So let's find that. So set role again allows you to identify which is the output variable. Let's try that. So here, and again, I'm not quite sure what these mean. Target role of the attribute only changed if parameter change. I don't know what that means. I guess we could go to help. So maybe it's label that we want, and we're trying to predict the house price. I think it's label. Label is sort of a synonym usually for class. Okay, so then the next thing after set role was nominal to numeric. Maybe we won't need that. And let's try linear regression. So go into here, linear regression. And there are different kinds of linear regression. But let's just use this one. And there's no kind of error message, so maybe it will just work without this nominal to numeric. And we don't need to replace. So let's just try it. Click up here. Okay. So here we have, again, the same kind of output. And here is the equation. Again, we haven't talked about that yet. But basically, this is an equation that looks like this. So basically, it's this. So x1 was in our data set was the transaction date. x2 in our data set was the house age, so the age of the house. The distance to MRT was x3. The number of convenience stores was x4 in the neighborhood. x5 was the latitude, and y is the price. So the equation is this: y equals 5.1 times x1 minus 0.2 x2 minus this x3 plus 1.3 this plus 226 x5 minus this constant. So that's called a regression equation. So in other words, when you put in a particular value for the transaction date, and you put in a particular value for the house age, like the house is 20 years old, and you put in a particular distance for the distance to the MRT, maybe it's 2 kilometers, and the number of convenience stores, maybe there's 3 in the neighborhood, and the latitude, whatever that might be, and then subtract this constant, that will, and fill all these in, and that will give you a y, and that's your prediction for the price. Okay, so that's what linear regression gives you. So these are called the coefficients, of course, for the particular input variables, and so they kind of measure the strength of these variables. So that's a little bit misleading, actually, to say that. But anyway, this is the regression equation. Now, this is called a linear regression equation because none of these have squares or like here, or cubes, or whatever. We don't have anything like that. They're all linear terms. It's not there, not there. And also, we don't have any terms like this. For example, x2, x3. Maybe we could have a term like 6. Maybe this might have been in the equation. Then this also would not be called linear. So when you have the product of 2 variables as part of the equation, that's not called linear anymore. So, but we didn't put in this. When we ran it, we chose linear regression, so it doesn't give us anything like this. It doesn't give us anything like this. what it's trying, basically what it's doing is we have, let's suppose we only had one variable. Let's suppose we just had this, because I can't draw all these variables on, the most I could draw is something where I'd have like one more dimension here, but I don't even want to do that. So if I had one more dimension, I could draw I could have two input variables. I could have like x3 and x2, but I don't even want to do that. I'm just going to have, say, x3 here versus the price, just because I don't want to try and draw more than that. So let's say when the distance to the MRT was, say, 1 kilometer, there was a house that cost this. There might have been another house that cost this. When it was 2 kilometers, maybe there was a house that cost this and a house that cost this. And when it was 3 kilometers away, maybe it was like this and like this. And maybe when it was 2.5, it was here. There was a price like that. And when it was 1.5, maybe it was here. And maybe when it was only a half a kilometer, there were a couple, so we might have data like this. So that is the data that we have. Again, we're only using one variable just because I can't picture more than one variable at a time easily. So what we're trying, when we say linear, that means, again, we're not allowing for squares and so forth. So that means we're talking about a relationship which has, we're talking only x3 in this case. So we're going to have some coefficient times x3, and then we will allow this term in there. So plus some constant term. So you recognize this as the equation of a line, mx3 plus something. So what we're looking for then is, let's use a different color, is some line, some line that models this data or fits the data. So maybe it looks like that. Just making, obviously, just a guess. But that's supposed to be a model for this data. And it's a linear model. So I chose, when I did rapidminer, I chose linear regression. So I only allowed for a linear model. So I'm not allowing for things like 2 here or 5 here, and not anything nonlinear. Now maybe the data, let me just add in a few more points here. Maybe or let me do it again. Let's try this. Let me try this and do this. And maybe the data, instead, let's just pretend that maybe the data looked like this. Looks like maybe it looked like that. So I could try and fit a line to that. Let's say I could do this. Whoops, that didn't work. Let me undo that. Whoops, that didn't work either. Uh-oh. Okay, let's try that again. Maybe I'll do this and that. Okay. And now let me go back to here and go to here and the line. Okay, so I could try and fit a line to this, but you can sort of see how I'd prefer not to have to just stick with linear in this case. I'd like to fit a line that's kind of curved, or I mean a curve that's kind of curved. So I might try to fit something like this to it. Maybe use f of x equals 1 over x. That looks something like this. So that seems to fit the data better. But that would not be called linear regression. And if I chose linear regression in rapidminer, it's not going to do this. But we can choose nonlinear regression. And then it might give us some other relationship rather than just a linear relationship. Maybe it would come up with this. Maybe it would come up with something else. But anyway, I only chose linear regression, so I'm forcing it to draw, in this case, a straight line. Or if we had more dimensions, let's see, can we do that here? If we had more dimensions, so now I could have 2 dimensions. So I could have like x3 here, x3 here, and what was some of the other ones? X3 was distance to MRT, and maybe x2 might be here. So we would have basically dots all over this plane, all over this surface here. Anyway, we won't go into that right now. So, anyway, we actually have more than that, so we can't even draw it in 3 dimensions. Anyway, the point is that we did linear regression here. And so going back to rapidminer, it shows this. So this is the equation. I don't know if you remember, but it was like 5 times x1, and then this times x2 minus this times x2 minus this times x3, and so on. That was the equation, and that's what it gave us. Going back to the data, it tells us a little bit more about the model and how good it is. We have to talk about that, but we won't do that right now. Okay, let's just see quickly how you do something in Excel. Let me just spread this out a little bit. I can see the names. And you do need to do something to do regression in Excel. You need to go to add-ins here. If you saw, I just went from File to Options, and then add-ins, and then you go to here. And you need this one called Analysis Toolpack. I didn't need this one. So you need to make sure you select this, and then click OK. And then hopefully in data, you'll see this thing here called data analysis. So let's suppose I want to use the age of the house to predict the price. So let's not use all of these variables. Let's just use one input just to show, you can sort of see the results more easily in that case. So we go to here and we find regression. We click OK. We have to say what's the output variable, that's the y, and the input variable, that's the x. And if you're going to include the labels at the top, then you have to click this, that it includes labels. So let's say the y is here. So I'm just going to select all of this entire column. So that's that. And then I'm going to use the other one. What did I say I'm going to do? I don't remember which column it is. The age, so go to there and go down to the bottom. And as I said, since I'm including the top row, which is the labels, I have to tell Excel that. And I want to get what's called the residuals plot, so I want to see the plot. Oh, and also, no, sorry, I want to see the line fit plot, not the residuals plot. Okay, so let's do that and just click OK. And so there, that's the picture. And so this was the house age versus the price. So we can see that as the house gets older, it seems like the price is going down to some degree. I don't know what the slope might not be that great, but it's definitely going down. Now, this line, this orange line, is an attempt to fit a linear model to the data. So that's called the line of best fit. Okay, so if you want to do the other way, another way, I moved the price, which this price data was over here. I moved it over here. It seems to be easier to input the two into a chart. So anyway, let's choose both of these. So these are the two variables that I want to chart, or I want to check the relationship between. So you go to Insert and this type, and you insert one of these, and there you can see the data. Let's make it bigger again. And this is the age, and this is the price. And then you click over here. It's something new, but this is, I guess, one way to do it. You go here to Trend Line, and click here, and click More Options. And then you can, now it's put in a linear model. So that's the same linear model we had before, but we can also choose a polynomial model. Now in this data, polynomial is not going to do much more than this does in terms of accuracy, but we could choose polynomial. Polynomial would allow for something to go up and down and up and down, and depending on the order of the polynomial. So this is a fitting like a parabola to this data. I'm not sure how good a fit this, or how good this is to do this, because now it suggests that as you get further away, the price is going back up. That doesn't sound right, but that's what the model shows. And you can do a third order, fourth order. And you can see fourth order sort of starts to come down a bit. Anyway, this data doesn't really justify any of these polynomials. It seems like linear would be the best model. But you can see how the polynomial model will give you more flexibility.